Okay, these are the 8.6 notes, and today's objective is to use proportions to calculate segment lengths. Okay, so we have several theorems in this section to put on note cards. The first one is Theorem 8.4, the triangle proportionality theorem, and that says if a line is parallel to one side of a triangle and it intersects the other two sides, then it will divide those other two sides proportionally. Now let's take a look at our picture here, and I'll show you what I mean. So we've got two lines that are parallel to each other, QS and TU, and that TU intersects the other two sides of my triangle, RQ and RS. And so because it's parallel to the third side, QS, then it divides my other two sides proportionally. So if TU is parallel to QS, then RT can be put over TQ, and that's proportional to RU over US. And Theorem 8.4 can be found on page 498. Okay, Theorem 8.5 is just the converse of the triangle proportionality theorem, so it's just the opposite of what we've already said. So this one says if a line divides two sides of a triangle proportionally, then it's parallel to the third side. So again, that's just the reverse of Theorem 8.4. Okay, then we've got Theorem 8.6 that says, talks about three parallel lines here. We've got three parallel lines. If they're intersected by two transversals, then they will divide those transversals proportionally. So if you take a look at this picture, you can see what I'm talking about. I've got three parallel lines, R, S, and T, and they've got two transversals running through them, L and M, and those intersect those three parallel lines, R, S, and T. So since R is parallel to S, which is also parallel to T, so if that's true, which it is in this case because they've got the arrows on those lines, then that means that UW can be written over VX, and that is proportional to V or WY over ZX. And Theorem 8.5 can be found on 498, Theorem 8.6 on 499. Okay, the last theorem in this section is Theorem 8.7, which is found on page 499. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So in this case, I've got triangle ABC, and it is bisected by the angle C is bisected by a ray CD, and because that ray CD bisects angle ACB, then that means that AD can be put over AC, and that is proportional to BA over BC. So the reason I know that CD is an angle bisector is because they show me these marks there that indicate ACD is equal or congruent to angle DCB. So I'll be doing 4 problems as examples. That's pages 502 to 504, number 12, 16, 22, and 34. Okay, on number 12, they're asking us to determine whether the information that they give us implies that QS is parallel to PT. In other words, do we have enough information to tell if these two lines are parallel to each other? Well, I know that the converse of Theorem 8.4, so which is Theorem 8.5, that says if these segments are proportional to each other, then that means that the lines QS and PT are are parallel to each other. So I'm just going to set up a proportion. So 5 over 12.5, that's ST over SR, should equal 4 over 10 PQ over QR. If those two are equal, then that means the lines are parallel. So I can just cross multiply. 5 times 10 is 50, and then 4 times 12.5 is also 50. So these lines are parallel to each other because QS divides the two sides of that triangle proportionally. And that's what Theorem 8.5 says. Okay, on numbers 15 through 20, you're supposed to take the given information and decide if that given information is enough to state that LP is parallel to MQ. So we're looking at this diagram right here. So the given information on number 16 is that MNQ, which is this angle, is congruent to LNP. Well, that's the same angle. Does that tell us that these two lines are parallel? Well, no, it doesn't. We would need two angles. For instance, we might need PLM, which is that one. If we knew that it was congruent to QMN, which is this one, then for sure we would know that LP is congruent to MQ because those are corresponding angles cut by the transversal LM. So you don't have enough information on 16, but you may have some more information on some of these other problems in this section. Okay, on number 22, I'm supposed to find the value of the variable. In this case, my variable is C. And I can see here that I've got a triangle that has a line that's parallel to one of the sides of my triangle. And that means, by virtue of Theorem 8.4, because this line is parallel to the third side of my triangle, it intersects the other two sides and it makes those other two sides segments proportional to each other. So all I have to do is set up a proportion and solve it. So I know that 20 over 12 is proportional to, and C is the one that goes with the 12, but this segment here, the one that goes with 20, is not 24 because 24 is the whole thing. So this segment could be found by doing 24 minus whatever C is. So I'm going to do that segment as 24 minus C. Now I'll cross multiply and solve. Cross multiplying, I've got 20 times C is equal to 12 times 24 minus C. Distributing with the 12, I have 288 minus 12C equals 20C. Moving my like terms together, 20C plus 12C equals 288. So 20C plus 12C is 32C. Then I divide 288 by 32, and that tells me that the variable is 9. So C is equal to 9, which means that this other segment is 24 minus 9, which is 15. Okay, so the last problem I'm going to do is number 34 on page 504, and I'm supposed to fill in all the missing line segments in this diagram, and I'm not going to finish this entire problem. I'll get you started on it so that you can see how to proceed on it. But the first segment I'm going to find is AB. And I know that AB is can be put over BD, and that is proportional to AC over CE. And the reason I know that is because of these parallel lines BC and DE. That BC is parallel to DE, and so Theorem 8.4 tells us that it divides the segments into proportional parts. So AB I'll call X, BD I'll call 11.9, AC is 8, and CE is 13.6. Then I'll go ahead and cross multiply and divide and get my answer. So after I cross multiply and divide, I get that AB is 7. Now, the next one I'm going to try to find is DF. Now I know that DF would be this part, and it would be proportional to AD. Now, so remember, now we're looking at this, the next largest triangle, which is this one, and DE is parallel to EG, and so that means that DF is proportional to AD, and then that means that EG would be proportional to AE. So the point is here, as you're moving down and finding these other side segments, you're going to have to make the triangle larger and larger, and you're going to have to add some numbers together. So DF we don't know, let's call that Y. AD I'm going to have to add together the 7 and the 11.9, so that's 18.9. EG is 6, and then AE I'm going to have to add the 8 and the 13.6, which is 21.6. Then I can cross multiply and divide. So after I do my cross multiplication and division, I get that DF is 5.25. So I'm going to skip over finding GJ, that other side segment, because that's just found the same way that we found DF. Just kind of enlarge your triangle and set up a proportion. But I do want to show you finding BC here, because this is a bottom segment and not a side segment. Now I would think that BC is proportional to DE, but really the only way that we could know that for sure, because we don't have any information, these parallel lines aren't really helping us with BC, but to know that BC is proportional to DE, I would really need to know that two triangles were similar to each other. So I would need to know that triangle ABC is similar to triangle ADE. Now remember, we can prove similarity by 3 ways. We can prove it by angle, by side angle, side, or by side, side, side. Well, I definitely don't have 2 angles, but I do have, or I might have side angle side, because I can see that these 2 triangles share an angle, angle A. So if I could prove that AD over AE was proportional to AB over AC, that would prove that my triangles were similar to each other. So let's do that. So I've got AD over AE, that should equal AB over AC. So AD is 18.9, remember I have to add 2 segments together there. And then AE is 21.6, again adding 2 segments, the 8 and the 13.6. And then AB is 7, and AC is 8. So now I'll just cross multiply and see if these 2 equal each other. So when I cross multiply, they do equal each other. They both equal 151.2. And so that means my triangles are similar to each other by side angle side, which then means that my third sides, BC, is similar to DE. Now I can already tell what the scale factor is. It's 7 over 8. But I'm just going to go ahead and set up my proportion. So I'll just go ahead and use AB over AC, and I'll fill in my missing information and find BC. Actually, my scale factor I don't think is 7 over 8. I was using the same smaller triangle each time. So let's go ahead and set this up. AB should be over AD and not over AC. So I've got BC, which is X, over DE, which is 10.8, and then AB, which is 7, and that should be over AD, which is 18.9. Now I'll cross multiply. So after I cross multiply and divide, I find that BC is equal to 4. So all of those bottom segments, you don't necessarily need to prove the similarity like I did, but I wanted to show you why it was working. It wasn't really from a theorem from this section, but it was because triangles were similar by side angle side, since they share the angle A. So your homework for this evening is pages 502 to 504, number 11 through 29 odd, and number 34.